18. A student carries out an experiment to determine the percentage by mass of copper in an ore containing copper in its +2 oxidation state. The student is provided with a sample of the copper ore, 1 molar per decimeter cube potassium iodide, Ki aqueous, and 0.02 mole per decimeter cube sodium thiosulfate, Na2S2O3. The student's method is outlined below. Step 1. Add an excess of warm nitric acid to 2.5 gram of the ore. The copper 2 compound in the ore reacts, forming aqueous copper 2 nitrate. Step 2. Filter the mixture to remove the unreacted rock. Step 2. Filter the mixture to remove the unreacted rock. Neutralize the filtrate. Step 3. Add an excess of aqueous potassium iodide, Ki aqueous, a precipitate of copper 1 iodide, and a solution of iodine, I2 aqueous, forms. Step 4. Titrate the mixture from step 3 using 0.02 mole per decimeter cube sodium thiosulfate in the burette. We've got the equation here for the reactions. 26.55 centimeter cube of 0.02 mole per decimeter cube of sodium thiosulfate are required to reach the end point. In step 1, the student observed that the bubbles of gas were produced. Suggest the formula of the copper 2 compound which reacted with nitric acid to form the gas, and write a full equation for the reaction. Formula is copper carbonate, and the full equation will be copper carbonate solid plus nitric acid, that gives copper nitrate plus carbon dioxide plus water, and this is the balance equation. B. Write an ionic equation including state symbol for the reaction in step 3, that reaction here. So we're adding an aqueous potassium iodide and a precipitate of copper 1 iodide, and a solution of iodine is formed. So we got copper 2 plus aqueous plus iodide, potassium iodide, forming iodine, as you can see there. So that's potassium iodide. So that's potassium iodide. Because potassium is expected to species, so that's why it's not shown here. So these two, this is the solutions. You're going to get copper iodide plus iodine. C. Suggest a suitable indicator for this titration and state the color change at the end point in step 4. We need to add starch solution towards the end, and the color change will be from blue-black, which is starch solution, to colorless. D. Determine the percentage by mass of copper in the copper ore. Give your answer to an appropriate number of significant figures. Let's have these beakers and the stand, and we're going to have the equation, the iodine being reacting with thiosulfate to then give the iodide. So we're going backwards now, and then the S4O62 minus aqueous. So now this is going backwards, and we can say that the mass of the mass ore 2.5 grams given, and we putting that in the nitric acid, so that's nitric acid, and we then filter that and then react it with potassium iodide in excess, and then iodine is being formed. A beaker here, so there's a beaker there, and so that's been, so we have a beaker there, and so that was titrated with 0.02 mole per decimeter cube of thiosulfate. And so in order to find a mole, that's concentration by the way, in order to find a mole of the thiosulfate, because if we know the mole of thiosulfate, we can work out the iodine. So number of mole is concentration times volume, and we know the concentration and we know the volume at endpoint. So we're given that, the volume at endpoint. So if we go back here, we can see from the question, this is volume at endpoint, 26.55 centimeter cube. That's why we got that. We convert that to decimeter cube by dividing it by 1,000. And then we get that amount of mole of thiosulfate. So number 2, so if we know the amount mole of thiosulfate, This is twice here, thiosulfate. So if we divide this mole by 2, we get a mole of iodine. So the mole of iodine, because it's ratio 1 to 2, the mole of iodine is going to be the mole of thiosulfate divided by 2, and that gives us the mole of iodine. Now if we know the mole of iodine, number 4, what we now need to do is to work out the mole of copper 2+. As you know, copper 2+ right up here is reacting with the iodide to then give the iodine. So we know the mole of iodine, and now we can work out the mole of copper 2+, which is going to be twice, because the ratio here is, well, if I look at this ratio here, iodine is 1, because we just got the iodine there. So iodine is 1 to 2 here. So if we know iodine, we have to times the copper 2+ by 2 by the mole of iodine. So that's why we're multiplying the mole of iodine here by 2, because in this equation, for every 1 iodine, we get 2 copper 2+. So this is 1 iodine. We have to times it by 2 to get copper 2+ mole. That gives us back the mole of copper 2+. If we know the mole of copper 2+, using mole equals molar mass times mole. So it's giving us mass, weighed mass, equals relative molar mass, or molar mass times mole. So we know the mass of copper 2+ in ore will be the relative molar mass of copper times the the mole, and that gives us the mass of 0.0337 grams. So we now know the mass of copper to be 0.0337 grams. And if we then work out the percentage of mass, which will be the mass we used from the ore, so it will be the mass of copper here divided by the mass used here times 100. And that gives 1.35%. The final answer would be 1.35. E. Explain whether the calculated percentage by mass of copper would be higher, lower, or the same if the following changes were made to the method. The potassium iodide was not in excess in step 3. Well, in step 3, if the potassium iodide was not in excess, lower and smaller, tighter volume will be achieved. If there's a tighter, smaller volume, then less iodine will form, assuming less copper 2+. Part 2. The burette readings were read from the top of the meniscus in step 4. Well, so the same, since the burette measurement measures by difference, and therefore initial reading minus final reading will cancel out. So if you measure from top in the beginning and you measure from top at the end, they will cancel out. That difference will cancel out. F. The student then modify the method in order to obtain a more accurate value for the percentage by mass of copper in the ore. The student decided to use 25 grams of the copper ore in step 1. What further modification should the student make to produce a more accurate value for the percentage by mass of copper in the ore? Well, add potassium iodide to 25 grams. Therefore, you're making iodine solution. Make the solution to 250 centimeter cube in a volumetric flask. Then you take 25 centimeter cube with pipette for titration. Do multiple titration until you get concordant results, same result, and take average mean.